Hello friends, I am your maths faculty from QLS Academy and the topic we will get to know in this session is polynomials. This is the third session of this topic, so we shall be continuing from where we left the previous session. Let's get started. Hope you will enjoy the session. Now suppose we have a polynomial 4y cube minus 2y square. अब इसे हमें factorize करना है. So we write the first term as 2 into 2 into y into y into y and the second term as 2 into y into y. Now you can see we have 2 into y common in both the terms. So we can take it out as common and then compose the remaining expression. Doing so we get 2y square into 2y minus 1. Hence we can see that on multiplying 2y square and 2y minus 1 we are getting the polynomial 4y cube minus 2y square. So these are the factors of this polynomial. Now taking example of 12, 3 and 4 are its factors because on multiplying them we get 12. Similarly, x plus 2 and x plus 3 are factors of a polynomial x square plus 5x plus 6. Now let us take one more example, a polynomial 2x square minus 5x minus 12. In order to factorize this polynomial, we break the middle term minus 5x into 3x and minus 8x. Now you must be wondering, how did we break the middle term and why didn't we write anything else in place of 3x and minus 8x? So this is an important thing to be understood. You have to take terms that on multiplication give a product that is equal to the product of the first and last term. That is, in this example, the product of 2x square and minus 12 is minus 24x square. That is why we chose 3x and minus 8x to obtain the middle term minus 5x, because the product of 3x and minus 8x is also minus 24x square. So on taking common terms out and rearranging the terms, we get the polynomial equal to 2x plus 3 into x minus 4. Here 2x plus 3 and x minus 4 are the factors of the polynomial. We can see that as the original polynomial had leading coefficient equal to 2, the coefficient of x in one of the factors is also 2. So this is how it's done. I just told you that for splitting the middle term, take terms such that their product is equal to the product of the first and last term. Now you must be wondering, how can I say this? Let me make it clear. Suppose a polynomial p of x is equal to x minus a into x minus b, where x minus a and x minus b are factors of p of x. Now on multiplying we get p of x equal to x square minus a plus b into x plus ab. Thus, for a quadratic polynomial having leading coefficient equal to 1, we need to find a and b such that the middle term can be expressed using them as well as the last term. But we cannot always factorize a polynomial this easily. Sometimes we may encounter a polynomial that is not very simple to break like this. In that case, we can find the factors by using the remainder theorem that we learned in the previous session. I told you that if the remainder is equal to 0, then the quotient and divisor are the factors of the polynomial divided. But for remainder theorem, we need a divisor. That is, we must have one factor already in order to find the another factor. So to find all the factors of a polynomial, may it be quadratic, cubic or any higher power, we can use the factor theorem. Now the factor theorem states that let f of x be a polynomial. If f of c is equal to 0, then x minus c is equal to 0 is a factor of f of x. And if x minus c is a factor of f of x, then f of c is equal to 0. For example, you are asked to solve the equation 2x cube minus 3x square minus 11x plus 6 equal to 0. Given that 3 is a 0 of this function. Since 3 is a 0 of the function, then f of 3 is equal to 0. The factor theorem tells us that x minus 3 is a factor of this polynomial function. Now if we divide the given polynomial with x minus 3, we will get the other factors too. For example, let f of x be equal to x square plus x minus 6. That is, f of x is equal to x plus 3 into x minus 2. Now if we put x equal to minus 3, we get f of minus 3 equal to 0. Again, if we put x equal to 2, we get f of 2 equal to 0. Since f of minus 3 is equal to 0, x plus 3 is a factor of f of x. Again, since f of 2 is also equal to 0, x minus 2 is a factor of f of x. अब अगर रिमाइंडर 0 आए तो ही कोशेंट और डिवाइजर फैक्टर्स होते हैं डिवाइडेंड के. Often, long division will produce a non-zero remainder. For instance, if you divide x square plus 3x plus 5 by x plus 1, you obtain the remainder 3. This proves that every polynomial cannot be factorized. For example, examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. Now, the 0 of x plus 2 is minus 2. Let p of x be equal to x cube plus 3x square plus 5x plus 6 and let s of x be equal to 2x plus 4. Then, t of minus 2 will be equal to 0. So, by the factor theorem, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. Again, s of minus 2 is also equal to 0. So, x plus 2 is a factor of 2x plus 4. Now, taking another example, find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Now, as x minus 1 is a factor of p of x, so p of 1 is equal to 0. Now, on solving this equation, we get k equal to minus 3. Now, if we are not given any 0 of the polynomial and you can't even predict them, then there's one more thing you can do. If we have a quadratic equation of the form ax square plus bx plus c equal to 0, then its two roots are given by the formula x equal to minus b plus whole root of b square minus 4ac upon 2a and y equal to minus b minus whole root of b square minus 4ac upon 2a. Now, what are algebraic identities? They are basically polynomials. An identity is an expression of equality that holds for all values of variables. I repeat, an identity is an expression of equality that holds for all values of variables. We shall be using these identities later at various places. Some of the algebraic identities are x plus y whole square equal to x square plus 2xy plus y square, x minus y whole square equal to x square minus 2xy plus y square, x plus y into x minus y equal to x square minus y square, and so on. We can use these identities to factorize or expand polynomial expressions. Now, let's recall what all we learned in this session. We learned how to factorize a polynomial expression by splitting the middle term, or if one factor is known, then by using the remainder theorem, other factors can be found. Or if any one zero is known to us, and at last, we learned a formula for finding the zeros of a quadratic equation. We also got to know about some algebraic identities. Algebraic identities have a wide variety of applications. So, you must learn these identities and use them wherever possible to ease out the problem. Hope you enjoyed this session. Keep practicing, and for any kind of information or queries, you may visit the link given below.